So in the end, what was the question? So in the end, what was the question? How do changes in the mass and volume of a boat change its density? If you take a boat and you put more mass in it, it becomes more dense. If you take that same boat and somehow stretch it out but don't put any more mass in it, it becomes less dense. So really this is about floating and sinking, but more importantly it's a little introduction to why do things float or sink. They do, but there is a reason, and engineers and scientists know those reasons and can make sure that before they build a building, before they build a boat, before they do any of the actual building of something, they can figure out how many people can go in that boat, how tall can that building be, how much is it going to cost to build, and how safe is it going to be. And that's what science and engineering helps us to learn better. But in this lab, there were really three things that I wanted you to learn about. One, I want you to be able to use and convert SI units for length, area, volume, mass, density. I want you to be able to apply math and the scientific method to solve problems, and I wanted you to be able to create and interpret data in a graph. Why do we use standard units to measure these things? Why do we use math to help us solve problems? Why do we take data in a table and turn it to a graph? In your conclusion, were you right or wrong? And again, it doesn't matter if you were right or wrong, just tell me. Were you right or wrong? Does it matter if you change mass or volume? Whether the density changes? If you change one side of an equal equation, then the other side is probably going to change too. Explain these three things. Remember, why? Don't just tell me that you used a graph. Why do we use a graph? Give an example where these ideas, graphing, densities, floating or sinking, using units to measure, applying math, where in your everyday life, do these things happen? Where do you use these things? And what was your biggest difficulty? What was your source of error? Don't say yourself, I made a mistake. Say what in the lab gave you the biggest problem. What was it that caused you to have error? So, those are the main parts of your conclusion. We've gone over how to do the lab, we've gone over how to graph the data, and now it's up to you to finish things up. Thank you, and will your boat float?